Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which prints extreme nodes of each level of binary tree in alternative order. First, let us take an example. The idea is to traverse tree level by level. For each level, we count number of nodes in it and print its leftmost or the rightmost node based on value of a boolean flag. We dequeue all nodes of current level and enqueue all nodes of next level and invert value of boolean flag when switching levels. Now let us see the algorithm. Let us also take a sample tree to test our algorithm. We pass the root node, which is 1, into function print extreme nodes, so root will point to 1. Note that we are using a queue data structure. We push the root node, which is 1, into the queue. Also, we initialize a flag variable to false. Since queue is not empty, we enter the while loop. We have node count, which will store the number of variables in the queue, and int n, which will store node count. Since queue has only one element, node count and n will be equal to 1. Now we dequeue all nodes of current level and enqueue all nodes of next level. We enter the second while loop and decrement n. We have another node cur, which will store the front element of queue, so cur will point to 1. Now we enqueue the left child of 1, which is 2. Next we enqueue the right child of 1, which is 3. Now we will pop the front element, which is 1. Since flag is false, we print cur, which is 1. Since n is 0, we come out of the second while loop and invert flag, so flag will now be equal to true. We while loop since queue is not empty. Now node count and n will be equal to 2 since there are 2 elements in the queue. Since n is greater than 0, we enter the second while loop and decrement count. Now cur will point to 2. In the next step, we push the left and right child of 2, so 4 is pushed and 5 is pushed. We pop 2 from the queue. Now flag is true and n is equal to node count minus 1, so we print 2. Again we loop and decrement n, so n will be equal to 0. Now cur will point to 3. Next we push the left and right children of 3, so 6 is enqueued and 7 is enqueued. Then we pop 3 from the queue. Since flag is true but n equal to node count minus 1 is false, so cur is not printed and we come out of the second while loop. We invert flag, so flag will be equal to false. Since queue is not empty, we continue with the outer while loop. Node count and n will be equal to 4 since there are 4 elements in the queue. We enter the second while loop and decrement n. Cur will now point to 4. We enqueue the left and right children of 4, so 8 and 9 will be enqueued. Then we pop 4 from the queue. Since flag is false and n is not 0, cur is not printed. We continue with the inner while loop and decrement n. Then cur will point to 5. We enqueue the left and right children of 5, so 10 and 11 will be enqueued. Next, we pop 5 from the queue. Since flag is false but n is not 0, nothing is printed and we continue while loop. We decrement n. Cur will point to 6. We enqueue the left and right children of 6, so 12 is enqueued. Then 13 will be enqueued. Next we pop 6 from the queue. Since flag is false but n is not 0, nothing is printed. So we continue with the inner while loop and decrement n. Cur will now point to 7. We enqueue the left and right children of node 7, so 14 will be enqueued, followed by 15. In the next step, we dequeue 7 from the queue. Since flag is false and n is 0, we print 7. Since n is 0, we continue with the outer while loop. We invert flag for the next level, so flag will be true. Since queue is not empty, node count and n will be equal to 8 as there are 8 elements in the queue. As n is greater than 0, we enter the inner while loop. Now curve will point to 8 and n will be equal to 7. Since 8 does not have any children, nothing is enqueued in the queue. We will pop 8 from the queue. As flag is true and n is equal to node count minus 1, we print cur. We continue with the inner while loop, so n will now be equal to 6 and cur will point to 9. Since 9 does not have any children, nothing is enqueued and we pop 9 from the queue. Since flag is true but n is not equal to node count minus 1, nothing is printed and we continue with the inner while loop. Now n will be equal to 5 and cur will point to 10. Again, 10 is a leaf node, so nothing is enqueued and we pop 10. Since neither of the if condition is satisfied, we loop again. Now n will be equal to 4 and cur will point to 11. Since cur does not have any children, nothing is enqueued and we pop 11 from the queue. Again, since neither of the if condition is satisfied, we decrement n and cur will now point to 12. As 12 does not have any children, nothing is enqueued and 12 is popped. We loop and now cur will point to 13. Since 13 is a leaf node, nothing gets enqueued and we dequeue 13. Now n will be equal to 2 and cur will point to 14. 14 is also a leaf node, so nothing is enqueued, and next 14 will be dequeued. Now n will be equal to 1 and cur will point to 15. Again 15 will be dequeued. Now n will be 0 and we come out of the second while loop. We invert flag, so flag will be equal to false. Since queue is empty, we come out of the second while loop as well. We have the final output. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.